This tutorial is about centering in linear regression. This tutorial, I'm going to focus only on multiple linear regression without interactions. The reason is that the involvement of interactions make the discussion complicated. Therefore, I'm not going to discuss that in this tutorial. So what is centering and how can we do that? It's very simple actually. You just put all the numbers minus their mean. So that's the centering. The reason why we center independent variables is that we want to make the intercept interpretable. So what I mean by saying that is that, for instance, some independent variable, for instance, weight or height, those variables, they do not have zero. Yes, usually weight or height are above zero. So if you want to make the intercept meaningful, then you need to center the independent variable that do not have a meaningful zero value. So let me explain by using this statement. So this is regression statement. So y, and this is intercept b0, regression coefficient for x1, regression coefficient for x2. If x1 and x2 have a zero value, then you can just assign a 0 to them. Then b1 becomes 0, b1 times 0 is 0, b2 times 0 is 0, then y equal b0. So now the intercept has the meaning. It means that it's the intercept, in this case, is the y value when both predictors are 0. The flip side of this question, the question is that if we center the x1 and x2, do we change the regression coefficient of b1 and b2 and then p-value? So that's actually, this is the question I'm going to answer in this tutorial, that namely, if we center x1 and x2, do we change the b1 and b2 and their p-values? The short answer is no. Centering only changes the intercept. Centering doesn't change the b1 and b2 at all. And in the next, I'm going to show this using R code. So I'm going to use R in this tutorial. So this is Arc Markdown. I'm going to post this PDF, post the link of this PDF in the video description. So later you can refer to that if you want. So there's 4 parts. The first part, we're going to simulate the data and going to do a multiple linear regression with the data without any centering. And then I'm going to center the independent variable, and then going to do a multi-linear regression with centering to show then we can compare the results of with centering and without centering and with centering to see how they are different. So let's first do the first part, which is simulate the data. So go to R. So we're going to simulate 2x. So we're going to like 2x, x1 and x2. Yes. So how can we do that? We're going to use the R known function and going to simulate 100, and the mean is, that's 2.5 maybe, and SD is 1. Okay, and then we say as x1, and we're going to do copy paste x2, and then also 100, and the mean maybe this time we're going to just 1.5, and SD still we can keep it the same. You can change it if you want, but we do not really have to for the purpose of this tutorial. And then we're going to simulate the 1y, yes, and then it's y. And so we can just copy paste, make our quicker. So the maybe being is 3. We keep the SD still is 1. So and then we can print out the x1 2, and you can print out the print the first. We do not want to print all the numbers. We just want to print the first 6 numbers, even though we have simulate 100 number for each of them. So we can just run it to see how it goes. Okay, so this should not be capitalized, so it should be SD. Okay, so I think now it should work. Okay, so we can see that we simulate x1, x2, and y, and then and this is the numbers, and then we're going to do linear regression. So this without any centering, yes. And so we're going to do a multiple linear regression RM, and then we're gonna y and x1 plus x2, yes. And we're going to say as a result 1, and going to write out called summarize result 1. Okay, good. And so let's print out. So this is the result, intercept x1, x2. And okay, so we get that. So now we need to do the centering to see if we center the x1, x2, how it looks like. So we can use the scale function. We only need to center the x1, x2, yes. We do not center y, so just remember. So we're going to x1, and then we want the scale. There's a parameter called force. And we say as x1 center. Similarly, we're going to do it to x2. We can also print out to see how it looks like. See. I mean, it print all the numbers, so I mean, probably we do not. So you can see that it is slightly different because I centered that. Okay, so we better use the head function rather than the print function, because the print function will print most of them, so head function is better. Okay, so the first 6 numbers, yes. So you can see that it's different from the previous one. So just center it. Now we're going to do the regression, yes. So we can just copy paste this R code, but we're going to change it to center. We're going to now use the center one, yes. We just say earlier, and then is result 2, yes. And then we run it to see how it looks like. Okay, so as you can see that the regression coefficient for the x1 is 0.02201. We can actually print title summarize result 1 again here, so that's make the comparison easier. So so this is the not center one, and this is the center one. As you can see that the regression coefficient for the x1 is exactly the same. The regression for coefficient for x2 are exactly the same. The only difference is the intercept. The intercept got changed. So and then we can also see that the t value and the p value are exactly the same. So the conclusion here is that, let me write out the conclusion here, is that for multiple linear regression, without intercept interaction item, centering x only change the intercept, so it doesn't change anything else. So if you you do not really care about the intercept, then in generally centering or not centering doesn't really impact. So in other words, you don't really need to do centering because that's actual work. Yes, you do not need to do that. So that's it. Thank you for watching.